QAISys collects data from 2 points in the medical imaging workflow, the point of exam completion and the point of diagnosis. This information is stored and organized in a database. The first step in the process is to collect basic data for all imaging exams, including the exam accession number, the date of the exam location, the type of exam, the exam modality, the time of the exam, and the performing technologist. These exam attributes serve as the basis for analysis and tracking. This data can be collected automatically through data transfers from a radiology information system, or it can be entered manually from exam logs if there are relatively low exam volumes and RIS is not available. Note that these simple exam records do not contain patient identifiers. The second step in the process is to collect feedback from the interpreting radiologist for exams that he or she considers to be quality deficient. It is important to note that this feedback is only required for exams that are quality compromised. This usually ranges between 1 and 5% of exams. There are a number of modes by which radiologists can convey feedback depending on the technology, configuration, processes, and preferences of the imaging organization. For our purposes, we only need to know from the radiologist the nature of the quality detraction and the severity of the quality detraction. The third major step in the process is to associate the feedback with the appropriate exam entry, while assigning a dissatisfaction value to the exam according to the nature and severity of the quality detraction. To do this, we select the exam entry and then choose Edit Detractions. This brings us to the DV input interface. Here we can add one or multiple detraction entries. To add detraction entries in the detraction details area of the DV input interface, we simply select the detraction type, select the severity, and click Add New Detraction button. We see that the system has added additional DV to this exam. Once we have attached quality detractions to the exam based on the feedback and determined their severity, we are able to distribute partial or full responsibility for the DV generation by each detraction between the various possible sources. The DV input interface makes this process very quick and simple. The possible sources of image quality detractions include technologist performance, patient-related issues, equipment limitations or malfunctions, or process deficiencies. Distributing DV in this manner allows us to account for factors that are beyond the technologist's control. It also enables us to track and analyze quality issues in more detail. For instance, it may be desirable to track reoccurrence of a particular equipment-related quality detraction. Finally, we are able to attach text to the detraction entries, allowing us to record specific radiologist comments of document correction actions taken for this particular instance of quality lapse. The Institute of Medicine states that the application of engineering concepts to the design of care processes is a critical first step in improving patient safety. The Institute strongly encourages the application of organized approaches to collecting data and errors and analyzing their causes, minimizing reliance on human memory, and standardizing routine aspects of care processes. Patient safety emerges from systems that are skillfully designed to prevent harm.